Hi Year 12, this is our second lesson for the topic single variable statistics. In this lesson we're going to look at displaying data. Last lesson we looked at types of data, organising data, grouped data and two-way tables. Now the type of graph that we choose depends on the type of data that we have. So for example, if we have numerical data, then we can use frequency histograms and polygons or stem and leaf plots. But if we have categorical data, then we can use column graphs, pie charts, and Pareto charts. So a frequency histogram is a statistical column graph, and you've been looking at these now for a number of years. Frequency histograms have really strict rules. Let's look at them. First one is we leave a gap before the first column. Secondly, we start the x-axis with the very first number that's in the x column, even if it's 0 or negative. There are no gaps left between the columns, and the columns sit over the top of the numbers. And a frequency polygon is a statistical line graph. We join the centers of the columns. Now, if you have a particular score that has a 0 frequency, make sure you bring the polygon all the way down to the x-axis. And the polygon will start and finish at the x-axis. If we have group data, then all we do is use the class centers for this x-axis here. Now, something you might not have covered in junior school is a cumulative frequency polygon. It's also called an ogive. Now we draw the cumulative histogram. Remember, cumulative frequency means we're adding on the frequency each time. So you should see these columns get taller and taller in height. And then the polygon, instead of joining the center of each of these columns, it joins the top right corner of each of those columns. Now the reason for that is so that we can use that ogive to estimate things like the median and the upper and lower quartile, but we'll get to that in another lesson. So let's have a go at drawing a cumulative frequency histogram and polygon. Now this data set, you can see I have already worked out the cumulative frequency. So let's draw the histogram. You can see here how I've started at 0. That's our first entry. So we've got 0, 1, 2, 3, 4, 5 along the x-axis. Because it's cumulative frequency, the column height is ascending. It's always going up. So there's our cumulative frequency histogram. The polygon, I'm just going to join the top right-hand corner of each of those columns, like that. Okay, let's move on to stem and leaf plots. Now this should be routine for you. Draw a stem and leaf plot for the following data. So you can see here that we've got some 10s, some 20s, some 30s, some 40s, and some 50s. And remember, this first digit here is going to be the stem. So our stems are going to be 1, 2, 3, 4, and 5. Now the leaves are the last digit, and they have to be in order. Now I have already ordered this data. If you get a data set that's not in order, you're going to have to arrange it in order first. But the leaves for our 10s are going to be 1, 5, 5, 9, like this. And filling in the rest of the stem and leaf plot, we get this. So this is the stem, and these are the leaves. And the key, 2/5, means 25. Now it's important to note the key in a stem and leaf plot because they can get quite complicated. For example, here we have a double-digit stem. 13/6 means 136. We can use decimals. 1/1 is 1.1. We can even split the stem. So in this case, you can see how I've got two parts to each of these stems, and here's our key. 2 without the asterisk, that goes from 20 to 24, and 2 with an asterisk goes from 25 to 29. And we can even get back-to-back stem and leaf plots. Okay, last thing for this lesson is the Pareto chart. Now this is new to the course. It's an economics chart. It's a combination of a column graph and a cumulative frequency graph. Now it's based on the Pareto principle, which you may not have heard of, but you may have heard of the 80-20 rule. It's named after an Italian economist, and he stated that roughly 80% of consequences come from 20% of causes. And the reason that we use the Pareto chart is to isolate the vital few, so the really important things, from the trivial many. So the first thing to note about a Pareto chart is that it is used for categorical data. And this one you can see on screen is about defects in shirts. And the columns, they are arranged from most frequent to least frequent. And then this cumulative frequency is converted to a percentage. So we haven't done that before. This is a cumulative percentage, and the polygon is drawn on top like this. So let's draw a Pareto chart for this data. Start with it. We've got color and frequency. So we need to work out our cumulative frequency and then our cumulative frequency percentage. Now, cumulative frequency is easy, isn't it? This is 240, add 230, add 200, add 95, add 27. So there's our cumulative frequency, and our total frequency is 792. To get this percentage, I'm just doing 240 divide 792 times 100. And there's our cumulative frequency. We should end up with 100% by the end, otherwise we've made a mistake. Now let's have a look at how we draw this. So down the bottom here, I've got my different colors, and then I have my columns. Can you see that? And they're starting from most frequent down to least frequent. Now, there's no real answer as to how you make this scale on the cumulative frequency percentage axis. You do need a second axis. But the 100%, some people will draw it at this point here. I have seen them draw it at, it's 100% goes all the way up to the total frequency, but that distorts the graph a little bit. Most of the graphs I've seen in the HSC, this 100% line is just slightly above here. So I doubt they would ever ask you to draw it in an HSC, so you don't need to worry too much about that. But you can see, now that I've decided to put my 100% there, which I've just counted up to 10 basically, then it was quite easy to draw this polygon in. Now, interestingly, Excel will actually draw a Pareto chart for you. So you might like to have a go at this. So there's the same data, color and frequency. I put a little formula in to calculate the cumulative frequency. In here, I made that one equal to B2, and then I created a formula in here, and it was equals C2 plus B3, and then I filled that formula down. And then the cumulative frequency, the formula is equals C2 divided by C6. I had to make that an absolute reference so that it wouldn't shift, and then I times it by 100, and I filled that down as well. Now what you do is you need to highlight all three of these, and you use your control key to do that. So as you're holding down control, color in this using your mouse, keep control held down and color this in as well. So when you lift off, all those areas should be highlighted. And then you go to Insert, All Charts and Combo. And we choose a column and a line graph because that's what a Pareto chart is. Now here's the only important thing you've got to do. With the cumulative frequency, this guy here, we need a secondary axis. That will give us up that percentage axis that we want. So there it is. You might want to label your axes, so you click on the graph, you go to Design and add a chart element. You can put frequency here, you can put cumulative frequency here, and you can type in a title. So let's finish off with a couple of past exam questions. I should mention that Pareto charts are part of the common content. So anytime they appear in the HSC, it's probable that they are in both papers, advanced and standard. So it'll be one of those questions where they use it to distinguish between the two cohorts. School collected data related to the reasons given by students for arriving late. The Pareto chart shows the data collected. What percentage of students gave the reason train or bus delay? Now, you can find this total here and then add up all of these frequencies. So figure out what the total frequency is and go, this frequency divided by the total frequency times by 100. That's a lot of work. It's much better to try and figure out how much this cumulative frequency increases to get to here, because that's what's happening here. So at this point, when we've added in slept in, family and appointments, we're sitting up here at, what is that, 86%. After we add in train or bus delay, we're up here at 92. So it's a pretty easy question, isn't it? From 86 to 92, that's 6%. And this question was from 2022. The table shows the types of customer complaints received by an online business in a month. What are the values of A and B? So, fairly routine question. It's asking whether we understand about cumulative frequency, but 98 plus 62 is going to give us A, and so A will be 160. And then to work out the cumulative percentage, we want to do 192 divided by 200 times by 100, which is 96. B. The data from the table is shown in the following Pareto chart. The manager will address 80% of the complaints. Which types of complaints will the manager address? Now, I'm quite critical of this question because it is badly worded. It's expecting you to understand that it is referring to the 80-20 principle, which is the basis for a Pareto chart. So it's implying that the manager is going to address the 2 or 3 categories of complaints that make up 80% because that's going to be best for the business, but it never actually says that. That's a pretty easy question. Stock shortage plus delivery fee, together they make 80%. And so that's the answer, and you probably would have got there anyway, but I can see how this question would have confused a lot of students. Okay, that's it for this lesson. Our next lesson is on measures of central tendency.